Okay, in 1.3, we are going to do linear applications, but before we do that, let's review some equations of lines information to make sure we're ready for the word problems. Okay, we've been using function notation a little bit already, but I'm going to remind you of it before we move forward further. Okay, this is function notation. It normally has a letter, and then in parentheses it has an x or a t. The way we say this is f of x. F is just a way of labeling your equation so you can keep track of different equations. Okay, the x is your input value or your x value. Okay, function notation can be used to represent ordered pairs or equations. So h of 2 equals 5 is how I say this. This represents an ordered pair. The input is the x value. The output is the y value. So this represents the ordered pair 2, 5. Okay. Let's look at the next one. So the next one's similar. This says k of negative 3 equals 7, which means the x is negative 3. And the y is 7. Now, why might we use this instead of this? Well, maybe there's two different equations. There's two different lines. So this h of 2 equals 5 tells me that the 2, 5 is on the h line, and the negative 3, 7 is on the k line. So it helps us keep track when there is more than one thing going on. Okay, they can also represent equations. So right here I have f of x equals 5x minus 7, g of x equals x squared. And when they say f of 2, they want me to plug 2 into the f function. When they say g of 3, they want me to plug 3 into the g function. So this is just a way of telling me which equation to use. So let's do each of these. So f of 2. I'm going to plug 2 in for x in the f function. So the f function is 5x minus 7. So I'm going to do 5x minus 7. Where the x is, I plug in the 2. And then I actually evaluate this. Minus 7 is 3. So if I do f of 2, I get 3. Or when I plug x in, I get y as my output. Let's go to the f of negative 4. Okay, so we're at f of negative 4. I'm plugging x in as my input into the f equation. So it's going to be 5x minus 7. For the x's, I plug in the negative 4. And then I do evaluate it if possible. So negative 20 minus 7 is negative 27. So f of negative 4 is negative 27, which again is just saying when I plug x as negative 4 in, I get a y value of negative 27, and I could graph that. Okay, last one, g of 3. G of 3. So my x is 3, and I'm plugging it into the g equation. This is f of x, this is g of x. So this is x squared. So I'm going to take x and square it. My x value is the 3. So g of 3, 3 times 3 is 9. So g of 3 equals 9. When I plug in x equals 3, my output is 9. Okay, let's look again at slope-intercept form and point-slope form, which we have reviewed before. Okay, we're going to look at how we can write the equation of a line from a graph, a table, or the given information, and when you would use slope-intercept form rather than point-slope form. Okay, slope-intercept form is y equals mx plus b. M is the slope, b is the y-intercept. Point-slope form, m is still the slope, and now I have a point x1, y1. So depending on the information, you'll use one versus the other. For example, one, we're going to use slope-intercept form. If I'm using slope-intercept form, they're giving me the slope, and they're going to give me the y-intercept. Okay, so for A, the line with slope 2, y equals, what's m? 2. mx plus b. What's b? B is the y-intercept. What's the y-intercept? The y-intercept is minus 7. So y equals 2x minus 7. Slope is 2, y-intercept is 0, negative 7. And what if they give me a graph? Well, I still just need the slope and the y-intercept. Okay, which one's easier? For this one, I can see the y-intercept right there is 0, 1. And even if they don't put the big dot on it, if I can recognize that it's clearly on an integer value, I will do that. Okay, the slope, I need to figure out the slope. To get the slope, I need to find two nice points, which they've nicely labeled for me, and determine the slope from one to the other. You can go up and left, or you can go down and right, but I'm going to do rise over run. I like to go start on the left. So I'm going to go down 1, 2, 3, 4. Down 4, run, 1, 2, 3, positive 3. So my slope is rise over run. So then what's my equation? Y equals mx plus b. So y equals negative 4/3 x plus 1 is my equation. Okay, now how about if they give me a table? Okay, I still just need the slope and the y-intercept in order to do slope-intercept form. Okay, what's slope? Slope is rise over run, or change in y over change in x. Okay, so let's do change in y over change in x. In the y direction, 11 to 8 is going down 3. And the x's in the same interval are going up 2. So my slope is rise over run. Okay, now you could find the slope. I could go from here to here. That would still be negative 3 over 2. I could also go backwards, as long as you go backwards both ways. This would be plus 3. This would be minus 2. So as long as you are consistent in your left and right, your rate of change will match. Okay, the y-intercept. Well, I know it's 0 comma something. So I'm going to look at the given information in the table. I have 0, 11, 2, 8, and 4, 5. The y-intercept is 0 comma 11. Okay, so equation y equals m x plus b. Okay, let's do one more slope intercept from the equation. From the table. Okay, slope, rate of change, or change in y over change in x, or rise over run. Now again, I can go from here to here. I can go from here to here. I can go backwards, as long as I do the same thing all the time. I either do which one looks easiest, or I just start from the first and go to the second. It doesn't matter to me. Okay, if I go from negative 10 to negative 2, I'm going up or down? I'm going up 8. If I go from 2 to 0, am I going up or down? I'm going down 2. So what's my slope? Rise over run, 8 over negative 2. Now 8 divided by negative 2 is just negative 4. So I'm going to make this negative 4. Okay, y-intercept. 0 comma, there it is, negative 2. Okay, so what's my equation? My equation is y equals m x plus b minus 2. Okay, so y equals negative 4x minus 2. Now if you find your slope differently, if I had gone backwards from here to here, I would have positive 12 over negative 12 over positive 3, which would still be negative 4, and we get the same answer. So if you're doing slope-intercept form, you should have a unique answer that is the same, even if your work is different. Slope-intercept form will always match. Okay, before we start writing some equations in point-slope form, I want you to remember that your point-slope form can be converted to slope-intercept form. So when we write the equation in the way that is the easiest possible. And then if necessary, we can always change it to the format we would like later. Okay, so this is point-slope form. I can see the slope is 6 and the point is 2 and 10. If I want to change it to slope-intercept form, I want it to be y equals mx plus b. So I'm going to go ahead and distribute first. 6 times x, 6 times 2. And then I wanted to say y equals, so I need to cancel the minus 10 by plussing the 10 over to here. And you don't need to write this little plus 10. I know some of you like it, and some of you are okay without it. Negative 12 plus 10 is negative 2. So this is slope-intercept form. Slope-intercept forms are unique and should always match someone else's. Your point-slope form does not have to match someone else's because there's so many points on a line that it could be a different version of the same answer. Let's try the next one. Just watch your negative signs. Go ahead and work ahead without me. Negative 4x, negative 4, negative 2, positive 8. And then if I minus the 3 over, should I put it here? I'll put it for you. Minus 3. 8 minus 3, I get positive 5. And you don't need to write that yellow mark. Some of you like it, some of you don't. So y equals negative 4x plus 5 is a unique answer. Point slope form could be different formats that are equally correct. Okay, now let's try some point slope form. Point slope form means they're giving me a slope and they're giving me a point, but it's not necessarily the y-intercept. It's just any random point. Okay, so what's my A? The line with slope 1/3, that's my point. And then that's my slope. Put through the point x1, y1. Okay, remember it's y minus something equals something, x minus something. The y minus the y value, the slope goes in the front of the parentheses, and then it's x minus the x value. So this is x minus -5, which makes it a +5. And this is point slope form. They ask you to write the equation of line. This is a valid equation. You can stop right there. And we don't actually convert it to slope intercept form unless it specifically asks me to. Okay, let's look at this one here. Okay. For B, I see the graph. What do I see? I see this nice point here, so I'm going to use that as my point. Although there's other points I could use. So that point is 4, 1. Now I still need a slope. Now why aren't I using the y-intercept? I can't tell exactly what that is. It's 3.6, 7. I have no idea. So that's why I'm not using a y-intercept. I do need the slope, so I need another good point, which they did not give me. So I'm going to keep going till I get to a nice corner. That's a pretty nice corner. I'm going to use that point as well. Okay, now if I want the slope, I can either rise, run, or rise, run, and I will get an equivalent answer either way. So if I go this way, I go down 2, I go right 3. So I got -2/3. Okay, I'm going to use point slope form to get my point. Okay, so y minus y equals slope m x minus, what's my x value? 4. Okay, so that's a good point slope equation, and I was using this point down here when I did this. Now if you're like, why didn't I pick the other point? The other point is, what is this, 1, 3? There's no reason I didn't pick. I could have easily done the other point. If I did the other point, I would have y minus y equals m x minus, what's the x value? 1. Okay. Okay, this is equally correct as this. They're actually the exact same equation. They're equivalent. If I were to solve it, I would get the same result. So I chose to do this equation, but I could have also chosen to do this equation. It would also be correct. Okay, let's do one from the table. Okay, I need the slope and a point. Let's do slope first. Does anyone look easier than the other? Yeah, so 3 to 7, I'm going up 4. 5 to 8, I'm going up 3. So my slope is 4/3. Okay, now for a point, do I have the y-intercept? No, 0 something, 0. I don't have 0 something. They gave me 3 points. They gave me 5, 3, 8, 7, 11, 11. It does not matter which point you use. I'm going to pick 5, 3 just because it's first or because the answers are smaller for no good reason. Okay, because I picked 5, 3, I'm going to write my equation like this. Y minus the y value equals the slope. And I could do x minus the x value. So I'm using this as my point slope equation. This is not the only answer. I could have used 8, 7. I could have used 11, 11. They're all equivalent. So if I had used 8, 7, it would be y minus 7, 4/3, x minus 8. If I had used 11, 11, it would be this one. And if I were to change all of these to slope intercept form, I would get the same answer. So I chose to do this answer, but this answer and this answer are equally correct. So do whichever one comes to you or looks easiest to you. Okay, go ahead and try the practice problems. Be careful because they're mixed up, so you don't know whether to use point slope form or slope intercept form. Pause the video while you're working and then check it when you're done. Some of these have more than one correct answer, and so it's up to you how you choose to write it. Okay, let's look at these answers. Yours could be a little different. For number 1, I had y minus 8 equals 3 parentheses x minus 4. For 2, I did slope intercept form, so I have y equals -2x plus 7. If you did point slope form, you have y minus 7 equals -2 parentheses x minus 0. Doesn't matter. Okay, for 3, my slope is 1/7. I chose to use the ordered pair 2, 4, but you could have used -5, 3 or 9, 5, and this number and this number would change, but your answer would be equivalent. Okay, for number 4, my slope was 6/2, which is 3. Oh, it's not. It's 6/3, which is 2. One moment. This should be a 2. Okay, so then for my equation, I should have y equals 2x, and I chose to use the y-intercept, which was 17. So I did y equals 2x plus 17. If you did point slope form, You might have y minus 5 equals 2 parentheses x minus 6. It's up to you. Okay, for 5, the slope was 2 because I went up 2 over 1. I did slope-intercept form, so I have y equals 2x minus 3. If you did point slope form, that's fine. Okay, for 6, my slope is 1/3, so that should match. For my ordered pair, I chose to use 2, 1, which is why I have a 2 and a 1 here. If you chose to do -1, 0, you would have an x plus 1 and a 0 here, and that would be an equivalent answer.